What's up, people? This is Nate Morris, MasterLSAT.com. In this video, we're going to master the first logic game from the May 2020 LSAT-Flex. So if you haven't already taken that test, follow the link in the description, try it first on your own, and then we'll master all the questions that you had trouble with together. Feel free to use the timestamps below to jump in between the questions. Okay, let's look at game number 1 from the May 2020 Flex. We're going to start by mapping it out. It says an investigator is trying to figure out the order in which 5 phone calls were made. So it sounds like an ordering game, a sequencing game, and it sounds like we have 5 variables fundamentally that we are putting in order, and they are represented by Q, R, S, T, and V, as you can see. And it seems that we are putting them in order 1, 2, 3, 4, 5. And in addition to that, there's also a secondary variable, which is that each call was one of 2 types, either local or non-local. So either lowercase l or lowercase n. And as always, we are going to put the uppercase letter on the top of the line, and the lowercase letter is going to go on the bottom of the line. So for each spot, there's whoever's going there, Q, R, S, T, or V. And whether that is a local or a non-local call, that'll be represented by L or N on the bottom of the line. And that's how we do any sequencing game with a secondary variable. So let's look at the rules. Rule number 1 says Quinn's call was right before V, but sometime after S. So Q was immediately before V, which looks like this, right? That's always how we show immediately next to. But sometime after Smith, which means that whole thing is somewhere after Smith, which of course we always show with ... That is the symbol for somewhere later. Next rule says S was a different type than V. S and V were not the same type. So we can go ahead and add this into this rule we already have. Since we already have S and V in this rule, we can basically show that whatever's underneath S and whatever's underneath V, whatever that letter is not the same. We'll put an equal sign and put a cross through it, so it's an unequal sign. We'll show that whatever those 2 things are not the same. That's rule number 2. So far, it's all conglomerated into one rule, which is always what you want to do whenever possible. You always want to aggregate rules whenever possible because it gives you less information to look at when you're looking through the rules. Next, Quinn and Tang were both local, so we can actually add part of that underneath this. We can just put a lowercase l underneath Q to show that Q is local. And independent of this whole structure, Tang is also always going to be local. That is what that will look like. T will be on the top of one of the lines, and L will be on the bottom of that line. And then the third call was non-local, so that we can add to our grid up here. We can show that whatever's on that third line is an N, right? Whenever there's a rule that applies to a specific spot on the grid, we always want to show it on the grid like we did with that last rule. So this is the setup. Let's go ahead and look at the questions. Question number 1 is an acceptability question, pretty straightforward. We just have to look through the rules, and we'll start with the easiest rule, which is that the third call has to be non-local, right? So let's just look through each of these answer choices and check to see if the third one is non-local. A, the third one is non-local. B, the third one is non-local. C, also the third one is non-local. D, however, the third call is Quinn and it is local. So therefore D cannot be the answer. And finally E, the third call is Roth's and it is non-local, so that's fine. Let's continue. Next rule, we will do that small rule on the bottom first before we get to the major rule. So T has to be local. That's easy to look for. A, I see that T is local. B, I see that Tang's is also local. C, Tang's is local. And E, we don't have to look at D because D is crossed off. And E also Tang's is local. So no luck with that rule. So now let's look at this big rule. Let's maybe split it up. Let's first look for S before Q and V and QV next to each other. So A, I see that S is before Q and V, but Q and V are not next to each other. So A is not correct. B, I see S is before Q and V, and Q and V are next to each other. Q right before V, so that's good. C, S is before both Q and V, and Q is right before V, so that's also good. E, I see is also good in that respect. S is before Q and V, and Q is right before V. So now let's look for the other parts of that rule. First of all, Q has to be local. B, C, and E, let's look at all of those. B, Q is local. C, Q is local. E, Q is non-local, so E is out. And finally, S and V have to be different types from each other. B, S is local and V is non-local, so that's perfect. C, S is local and V is also local. So C breaks this part of that rule. And so therefore that is not the answer, and we are left with B, which is, of course, the correct answer. Question number 2. If Roth's call was second, then which of the following is something that must be true? So, of course, we always start by making the if true. We only have to read those first few words before we know what we have to do to get to work. If Roth's call was second, so we go ahead and, without even thinking, we just make that if true. We draw out a scenario, as we have here, where R is second, right? And, of course, we copy that N out under the third line because that's always true. This much we can do without thinking. Now we go ahead and look for inferences, right? We want to make the if true and look for inferences. So that first rule is going to tell us a lot. That big rule is going to always tell us a lot. The Q and the V have to be next to each other, so that limits that to the last 3 spots in this case. But it couldn't be 3 and 4. It couldn't be there because Q has to be local, and 3 is always non-local. So therefore, Q and V must, in this situation, go there, and of course Q would be local, so we can put an L there. Right? And that leaves 2 remaining capital letters to place on top of the lines, S and T. But looking at what we know about those letters, T has to be local, right? We're just looking at the rules to see what we can figure out. And since T has to be local, T can't go in the third spot since that's non-local. So T would have to go first, and that would be local. And then S would have to go third, which is non-local, which means according to this rule, since V is different from S, V would have to be local. So we just figured out a lot of information. Let's go ahead and look through the answers to see which of these must be true. A, of course, is impossible. The first call is not non-local. It actually is local. The opposite of A must be true. B, the second call we see is the one call we haven't figured anything out about. So B doesn't have to be true any more than E has to be true, right? B and E are both about that second call, which seemingly can be L or N since we've already followed all the rules. So nothing that we do in spot number 2 can break anything. C, the fourth call is definitely not non-local. As we can see, it actually is local, which leaves us with D. The first call is local. That must be true. We figured that out about a minute ago, right? So we already had the answer on the page. This was a pretty straightforward question. All we had to do is make the if true, look at the rules, look for inferences, and this answers itself. Number 3, if Tang's call was 5th, once again, just like in number 2, we have to just immediately start by making that if true and looking at the rules and looking for inferences. So that's what we already have up on the page here. T is 5th. We just do that without even thinking. And of course, the N we can always put under spot 3 without even thinking because that's always true. And now let's look at the other rules to see if we can find any inferences. The most obvious one being that according to this T rule, right, we put T down, so we want to look for rules with T. And of course, there is one. It tells us that T has to be local, which means we can put an L over there. Now let's look at this major aggregate rule over here and see that the QV, since the QV has to be after S, it couldn't be in the very first 2 spots, right? But it also couldn't be there because Q is not allowed to be non-local. As we can see from that rule, Q has to be L. And therefore, the only place that Q and V can fit is in 2 and 3, right? It couldn't be 1 and 2 because S has to be before it. And it couldn't be 3 and 4 because Q has to be local, not non-local. So the only place we can fit that is here so that Q could be local and so that also Q and V could be after S, which of course would have to go in spot 1 here. That's the only way that it can fit before Q and V, which of course only leaves one more letter, R, to go in spot 4. Now, what else do we know? What's the only component of the rules that we haven't used so far is that S and V have to be different from each other. Since we know that V is N, S will have to be L, and that seems to be all of the inferences that we can find. So let's look at the answers. Which of the following could be true? A, sure, the fourth call could be non-local, right? This fourth is the only thing that is an option that we have. This fourth call could be N or L. And therefore A is the answer and we're done. Let's look at the other answers and see why they can't be true. The second call being non-local contradicts with what we have. This is clearly supposed to be local. C, the first call being non-local, again, contradicts with what we have. Clearly the first call is supposed to be L for local. D, Smith cannot be third. As we can see, Smith has to be first. And E, Roth cannot be first. As we can see, Roth has to be fourth. So all of these other answers cannot be true. Of course, we already knew that. because A could be true and therefore is the answer. Again, a pretty straightforward question. Number 4, once again, for the third question in a row, we have an if to make true. If Roth's call was local. So in this case, we can't make it true by putting it on the grid because it doesn't tell us whether it goes first, second, third, fourth, or fifth. It just tells us that it's local, which means we have to just put this as a separate rule, basically like a rule number 4 in addition to the 3 rules that we already have for this particular question. And if we look for inferences, right, because we always want to make the if true and look for inferences, can we figure anything else out once we know that Roth is local? Well, nothing obvious jumps out at us from looking at the rules because Roth is not in any of the other rules, right? So telling us that Roth is local doesn't really affect a whole lot. And therefore, I would say there's nothing obvious jumping out in the way of other things we can figure out. Once you tell me that Roth is local, there doesn't seem to be anything else we can definitively determine from that from looking at the other rules. So therefore, let's move on to step 2, which is test out the answer choices. This question says, if Roth is local, then which of the following must be false, which is another way of saying which of the following cannot be true, which means we go ahead and try to make each one true, one at a time, to see which one doesn't work. So let's try A. If Roth is local, could Quinn be fourth? Now, here is a shortcut. We can look at the page and we can look at the 2 scenarios we already have where Roth could have been local. As you can see, in number 2, Roth could have been local. And in number 3, Roth could have been local, as we pointed out on those respective questions, which means that anything that we made true in those 2 scenarios, we already know is not the answer to this question, right? A, Quinn was fourth. We did that in number 2. Quinn was fourth. Roth was local and Quinn was fourth, which means we already inadvertently tested out for A when we did number 2. So there's no need to do this again because we already made Roth local and showed that A could be true, that Quinn could be fourth while Roth is local, and therefore A is definitely not the answer. We don't have to test it out if we've already tested it out in another question with this if being true, right? Same thing with B. In number 2, Roth was second and Roth was local. Since we made the if true and we made B true in another question already, number 2, we don't have to test B out on number 4. We've already done it. And since we're on a roll, let's look at the other answers because it seems like in number 2, we also did both D and E, right? Teng was first and Roth could have been local, and Witt was fifth and Roth could have been local. So if Roth's call was local, A, B, D, and E, we can already see on the page could have been true, and therefore they cannot be the answer to this question. We're looking for the one that cannot be true if Roth was local, which leaves us with C. It's the only one we haven't already made true in the past, and therefore that must be the answer. So therefore we're actually done the question. We don't even have to do anything on this question. It's already answered for us by looking at number 2. Now, if we did want to test out C for whatever reason to show why it cannot be true, let's go ahead and do that. So if S is second, then we know that third is always N. We would know that QV would therefore have to go there because Q can't be third because third is N and Q has to be L. And then R would have to go first so that it could be local, which leaves T to go third, but T is not allowed to be N because T has to be local also. So that's a problem. If T and R have to both be local, then there's no one left to go in this third spot, and therefore that's why C doesn't work. But of course, we already knew that it wasn't going to work because the other answers have already been tested. So that's it for number 4. As you can see, we didn't have to actually do anything on this question. Number 5, probably the trickiest question on this game, but still obviously very doable. If the first call was non-local, so of course, without even thinking, we just go ahead and make that if true, as we have up here on the page. We make the first spot non-local. Of course, we always know the third spot is non-local, so that is just part of the wallpaper. We can do that without thinking, right? The question asks then for exactly how many of the people's calls can we figure out what position they go in, which means there are going to be some inferences here. So let's go ahead and look to see what inferences we can find. And let's probably look towards that big major rule first because that's going to be the hardest to take care of. The QV block has always been the most difficult thing to place because of how restricted it is. On the one hand, it can't go in the first 2 spots because it has to go after something. And on the other hand, it also can't go in a place where Q is forced to be non-local because Q has to be local. Which means in this particular scenario, it seems like the only possible places it could go would either be there, right? Or perhaps there, right? Either 2, 3 or 4, 5. It could never go 1, 2. It can't go at the beginning because it has to be after S. And it also couldn't go there because Q is not allowed to be on top of an N, which gives us seemingly 2 possibilities. However, let's investigate this first possibility. If Q and V were 2 and 3, S would have to be right before it, right? And then S and V would have to both be non-local, which would break the rule that tells us that S and V have to be different, which means that's not going to work either. Which tells us that by process of elimination, Q and V must therefore go over here, right? It cannot go in any other place, right? Because like we just showed, had we put it there, S would have to go first, and then S and V wouldn't be different types from each other. And there's no other place that it can go either, right? As we said, we couldn't put it there because Q's not allowed to be non-local. We couldn't put it there either because, well, first of all, Q's not allowed to be non-local, and second of all, Q's not allowed to be first because it has to be after something. So therefore, we know that Q and V have to be 4th and 5th, so that's at least 2 letters that are determined. Now let's look at the remaining rules. T has to be local, which means T cannot be 1st or 3rd, which means T has to be 2nd. Right? That's the only spot left that is allowed to possibly be local. And now the 2 letters that we are left with are R and S. Now, it seems as if they are interchangeable, right? There's no reason why R has to go 1st or 3rd or why S has to go 1st or 3rd. It seems as if they are 100% interchangeable because either way, the S is going to be earlier than the Q and the V, so we are going to observe that sequence, right? We know that Q is local. We always know that Q is local. V is going to be the opposite of what S is, and either way, S is going to be N because 1 and 3 are both N, which means V is going to be L. But as you can see, R and S are interchangeable, which means the answer to the question, how many of the calls can their positions be determined? The answer is 3, right? 1, 2, 3. R and S are up for grabs. They're interchangeable, but T, Q, and V are all forced into position. And therefore, the answer to number 5 is C. If you found this video useful, don't forget to hit subscribe. And for thousands more clear LSAT explanation videos, go to masterlsat.com.